Okay, problem number 5. It says prove the following trigonometric identity, which is the cosine of x over 1 plus the sine of x plus the tangent of x can equal the secant of x. Let's have more stuff to work with on the left side. I will prove this identity by solving from the left side. The first thing to make note of is we know that the tangent of x is also equal to the sine of x over the cosine of x, which would give us the cosine of x over 1 plus the sine of x plus the sine of x over the cosine of x on your left hand side. Next thing we need to do is to give it a common denominator by multiplying the denominators here, which would give us the cosine of x times 1 plus the sine of x. Now, as I multiplied the cosine of x over here on this denominator, we must also do it with the numerator. So that would be give us the cosine of x, cosine squared of x. And then we'd multiply 1 plus the sine of x to this numerator over here, which would give us positive sine of x times 1 plus sine of x, giving us this right here for our fraction. Now, my next part, I want to split these areas and work with them. From here, we also know the cosine square of x is also equal to 1 minus sine square of x. On this side, I want to expand out, which multiplying sine times 1 would give me sine x, and then multiplying sine x times sine x would give me sine square x. With that, I end up with 1 minus sine square of x plus sine x plus sine square of x over the cosine of x times 1 plus sine of x. From here, we would want to group together the similar functions, or similar signs, which we have the negative sine squared of x and positive sine squared of x would cancel each other out. This would leave us with 1 plus the sine of x over the cosine of 1 plus the sine of x. From here, we can cancel out that, which leaves us with 1 over the cosine of x. And from here, we know that the cosine of x, the cosine of x equals 1 over the secant of x. Using our fractional, we will do a secant, which it would actually leave us with, just a moment, I would have enough room to leave us all up here, but I'm not going to. Which would leave us with 1 over 1 of the secant of x, which, using our fractional, flip this and multiply, and we would be left with the secant of x equals the secant of x, thus proving that the original cosine of x over 1 plus sine of x plus tangent of x is equal to the secant.